This chapter is all about ARM and ARM processors. Before we dive into the details, let's first get a clear idea of what ARM means. You've probably heard the term ARM, especially when talking about smartphones, tablets, or other portable devices. So, what exactly is ARM? ARM originally stood for Acorn RISC Machine and later became Advanced RISC Machines. The key word here is RISC, which stands for Reduced Instruction Set Computer. This is a type of processor architecture that uses a small, highly optimized set of instructions, rather than a large, specialized set. Think of it like having a small set of very versatile tools instead of a huge toolbox with a different tool for every single job. The main advantage of this RISC approach is that it leads to processors that are simpler, smaller, and incredibly power efficient. This is precisely why they've become so dominant in the world of mobile and embedded electronics, where battery life is critical. Now, here's a very important distinction to make, which is hinted at by the title, ARM and ARM processors. ARM, the company, doesn't actually manufacture the physical processor chips themselves. Instead, they design the processor architecture, the fundamental blueprint, and they also design specific processor cores based on that architecture. They then license this intellectual property, or IP, to hundreds of other companies like Apple, Samsung, Qualcomm, and many others. These companies take ARM's designs and integrate them into their own custom chips, which we call systems on a chip, or SoCs. So, when we talk about ARM, we might be referring to the company, the architecture, or the instruction set. When we talk about ARM processors, we're talking about the actual physical chips created by companies that have licensed ARM's technology. It's a crucial difference. In the following sections, we're going to explore this world in more detail. We'll look at the different products ARM offers, the various families of ARM processors, and then we'll dive deep into specific architectures and processors to understand how they work and what makes them so popular. This outline gives us a clear roadmap for what we're going to cover in this section. We'll begin with a broad look at ARM products. This is to give you a sense that ARM as a company offers more than just the processor cores themselves. They license a wide range of intellectual property, or IP, which includes things like graphics processors, system components, and software tools. From there, we'll narrow our focus to ARM processors specifically. We'll discuss the different families of processors ARM has designed, what their intended applications are, and why you might choose one family over another. This will help you understand the landscape of ARM's processor offerings, from the high performance, a series, to the real-time, R series, and the microcontroller, M series. After that, we'll get more technical and dive into a specific and very important architecture, the ARMv7A, and the family of processors built upon it, the Cortex-A series. This architecture is really significant because it powered a huge generation of smartphones and other mobile devices. We'll explore the key features that make it so suitable for running complex operating systems and demanding applications. Finally, we'll zoom in even further to look at one of the most famous members of that family, the ARM Cortex-A9 processor. By examining a specific processor in detail, we can see how the architectural concepts we've discussed are actually implemented in a real-world, widely used product. So, you can see we're moving from the big picture of the company, down through the architectures, and finally to the nitty-gritty details of a specific processor design. This outline gives us a clear roadmap for our journey into the world of ARM. We're going to break down this complex topic into 4 main sections to make it easier to understand. First up, you can see ARM products is highlighted. This is our starting point. We're going to begin with a high-level view, looking at the entire ecosystem ARM provides. This isn't just about the processor cores themselves, but also includes the software tools, physical components, and support systems that surround them. Understanding this big picture is crucial before we dive into the specifics. After we've explored the broader product landscape, we will narrow our focus to ARM processors. This is where we'll start to dig into the core technology that ARM is most famous for. We'll discuss the different types and families of processors they design. Next, we'll get even more specific by looking at the ARMB7A architecture and Cortex-A series. In ARMB7, A stands for application, so this architecture is designed for devices that run rich operating systems, like your smartphone or a digital TV. We'll explore the features of this architecture and the popular Cortex-A series processors that are built upon it. Finally, we'll cap it all off with a deep dive into one very important processor, the ARM Cortex-A9. By focusing on this specific example, we'll see how all the concepts from products and architectures to specific features come together in a real, widely used piece of technology. So, the structure is a logical funnel. We'll go from the general to the very specific, which is a great way to learn. Let's get started with our first section, ARM products. When you think about ARM, you probably just think of the processor, the brain inside your smartphone. But this page shows us that ARM's business is much, much bigger than that. In fact, ARM's main business isn't selling physical chips. It's selling the designs and licenses for technology, which we call intellectual property, or IP. The image of the tablet with its internal system on a chip, or SoC, is a perfect illustration of where all these products come together. Let's break down these product categories. First, and most famously, we have processors. These are the core CPU designs that ARM is known for. This slide lists Cortex-A, ARM, and Secure Core. As we'll see later, these different series are tailored for different jobs. For example, the Cortex-A series is for high-performance applications like you'd find in a smartphone. The R series is for real-time systems that need to respond instantly, and the M series is for smaller, embedded microcontrollers. Next is system IP. A processor is powerful, but it's useless if it can't communicate with other parts of the device, like memory or the screen. System IP is like the nervous system of the chip. It connects everything together. ARM provides products like CoreLink, which is an interconnect fabric, and AMBA, which is a standard protocol for how these different blocks on the chip talk to each other. CoreSight is a technology for debugging, allowing engineers to see what's happening inside the chip. Then there's multimedia. Modern devices are all about rich media experiences. The 3D graphics label popping out of the tablet screen points directly to this. ARM's line of Mali graphics processors, GPUs, along with their video and display processors, handle everything from gaming to high-definition video playback. Now, physical IP is a bit more technical. Having a design for a processor is one thing, but manufacturing it on a tiny piece of silicon is another. Physical IP provides the pre-designed, fundamental building blocks, like logic gates or memory cells, that are optimized for a specific manufacturing process. Think of it like a set of high-quality, prefabricated Lego bricks. Using them helps chip makers build their complex designs faster and more reliably. Of course, to build something this complex, engineers need good tools. ARM provides complete software development toolchains like DS5 and KeelNDK, as well as hardware debug adapters. These are the hammers, wrenches, and diagnostic scanners that engineers use to design, program, and test their ARM-based systems. Finally, ARM provides extensive supports. This includes training courses, detailed documentation, and a developer community called ARM Connect. A technology is only as good as its ecosystem, and ARM invests heavily in supporting the thousands of companies that use its IP. You can see the logos of many of these partner companies in the background, representing this huge ecosystem. So, this page gives us a great overview. ARM provides all the key ingredients: the processor, the interconnects, the graphics, the physical building blocks, the tools, and the support that allow companies like Samsung, Apple, and Qualcomm to create the powerful and efficient chips at the heart of the devices we use every day. Having seen the big picture of ARM's entire product ecosystem, we're now going to zoom in on the most fundamental part, which is highlighted here on our outline: ARM processors. This is really the heart of ARM's business. While the last section showed us everything from software tools to physical IP, this section will focus specifically on the processor cores themselves, the brains that do the actual computing. As you can see from our roadmap on this slide, we'll start by exploring the various types of ARM processors and their applications. You'll soon see just how widespread they are. After that, we'll get more technical and dive into a specific architecture, the AMBA AXI, which is incredibly important for devices like smartphones and tablets. We will also look at the Cortex-A series of processors that are based on this architecture. Finally, to bring it all together, we'll do a case study on one of the most successful processors from that series, the ARM Cortex-A9. So this outline just gives us a clear plan for the next part of our discussion, moving from a general overview of processors down to a very specific example. This page gives us a fantastic visual overview of just how widespread ARM processors are. You can find them in almost every type of electronic device you can imagine. The title says ARM processors and applications, and that's exactly what we see: a whole universe of applications. To make sense of this variety, look at the blue bar on the left with the letters M, R, and A. This isn't random. It's a way of categorizing these devices based on the type of processing power they need. This M-Ray classification is a core concept for understanding the ARM ecosystem. Let's start at the top with M. M stands for microcontroller. The devices in this top section are things like intelligent toys, utility meters for electricity or water, and even large appliances like refrigerators and washing machines. What do these have in common? They need a small, efficient brain to perform a very specific set of tasks. They need to be cost-effective and, very importantly, extremely power-efficient, sometimes running for years on a single battery. They are what we call deeply embedded systems. An intelligent vending machine, for example, doesn't need to browse the web, but it needs to reliably handle payments and dispense products. This is the domain of the Cortex-M series processors. Now let's move to the middle section, labeled R. R stands for real-time. Look at the devices here, things like printers, hard drives, and networking equipment. These applications have a critical requirement: timing. A real-time processor has to respond to events and complete tasks within a strict, guaranteed deadline. If it's too slow, the system fails. Think about the anti-lock braking system in a car. It must react instantly. That's a real-time application. These systems, which are often powered by Cortex-R series processors, are all about reliable, predictable, and high-performance operation where timing is everything. Finally, we get to the bottom section, which stands for application. These are the devices we're probably most familiar with in our daily lives: powerful smartphones, tablets, laptops, and smart TVs. These are high-performance application processors. They are designed to run rich, complex operating systems like Android, iOS, or Linux. They handle sophisticated user interfaces, browse the internet, play high-definition media, and run all sorts of apps. Performance is key here. These devices, running on Cortex-A series processors, are the powerhouses that deliver the rich, interactive experiences we expect from modern computing. So, this MRA structure beautifully illustrates ARM's scalability. They provide solutions ranging from the tiniest, most power-efficient microcontrollers for simple devices, to highly reliable processors for time-critical systems, all the way up to the high-performance engines that power our mobile digital lives. As we move to the next page, we'll see exactly how these letters, M, R, and correspond to the specific processor families that ARM offers.